Hello everyone. In this third introductory session, we'll help you make 8086 microprocessor bus connections. 8086 microprocessor has 20 bits of address lines and 16 bits of data lines, and they are in multiplexed manner. So we need to use appropriate circuitry to demultiplex those address lines and data lines. So as you might have noted, I've retained the previous circuitry, and I'll add few extra components to demultiplex your address lines and data lines. So first, we'll start with demultiplexing address lines. For demultiplexing address lines, we'll make use of a D-latch along with address latch enable signal from the microprocessor. Since Proteus has octal D-latches, we'll need 3 octal D-latches in order to demultiplex address line number 0 to address line number 19. So we'll search for the component, place component from library. The IC number for octal D-latch is 74373. You can find it in the results. I'll press OK, the component will be added. So I need to have 3 instances of 74373. I'll place it adjacent to microprocessor. Let's say I'm keeping it over here, first instance which will help me demultiplex address line number 0 to 7. Next, the D-latch which will help me demultiplex address line number 8 to address line number 15, and finally the third D-latch, it will help me demultiplex address line number 16 to address line number 19. So these are my 3 D-latches. Before starting, I need a bus at the input and I need the bus at output. So I'll introduce bus by going to the terminal and choosing bus. I'm keeping it over here to the input side of the latch, and I need another bus at the output side of the latch. So I'll take X mirror of input bus as well as output bus, and I'll draw the bus. So the first bus is going to be common for first 2 latches, input as well as output. I'll first rename the bus. Please pay attention to the mnemonics that we use for giving the labels for buses. It has to be first AD followed by square brackets 0 double dot 15 square bracket complete. That is my input bus, and at the output I'll get demultiplexed bus, that is A 0 to 15, right? So the buses have been drawn for the first 2 latches. Accordingly, we'll add bus terminal for the third latch, terminal bus, input bus, output bus, again mirror image, X mirror. So I'll draw the bus. Right, so the label for input bus for the third D-latch is going to be A 16 to 19, since it's multiplexed with some other signals, and the output is going to be A 16 to 19. Right, so I've got input buses and also drawn the output buses. I need to make intermediate connection, that is your first multiplexed address and data bus is going to be connected to the input of first D-latch. Accordingly, I'll make the connections. Since the connections are bit tedious, I won't be drawing all the connections, but I'll give you the bigger picture at the end of this session. So I'm currently drawing the output buses. These are demultiplex address lines. Accordingly, you can follow the same procedure to complete all your connections for the second latch as well. Input buses, output buses, they are connected to the output lines. Same procedure for the third latch, and then finally we'll move on to the control signals. As you might notice, we have got 2 control signals, output enable bar and latch enable. So output enable bar acts as chip select signal and we'll be permanently connecting it to ground. So terminal ground, it's active low signal, so we are keeping it enabled throughout our operation. I've connected it to ground. Same way, the other output enable of the second D latch is going to connect it to ground, and the third latch also we connected to ground. About the second control signal, latch enable, we'll be connecting it to address latch enable of your microprocessor, that is your pin number 25. I've connected it over here. We need to take out the same wire, connect it to latch enable with the second latch, and finally the third latch enable. So that's it. We are done with address line demultiplexing. Now we'll start with data line demultiplexing. We have got 16 data lines, and since your data lines are bidirectional, we'll make use of bus trans receiver. So the pin number for the bus trans receiver is 74245. We'll search in the component list, component from libraries 74245. Yeah, octal bus trans receiver. I'm keeping it over here next to the D latch, and I'll need two bus trans receivers since your width of data lines is 16 bits and your single bus trans receiver is of the size 8 bits. Same thing, I'll make use of multiplexed address and data line at the input, and the output of bus trans receiver I'll get demultiplexed data line. So again, I'll place a terminal over here, bus output bus terminal bus. At the output I need to take X mirror. Now I'll draw the buses. It will be common for both the trans receivers. Done. I need to label it, right? So AD 0 to 15, and at the output you'll get D 0 to 15, right? So the same procedure that we'll be following, connecting the input terminals to the input buses, connecting output terminals to the output buses. Still I'm not connecting each and every terminal because it's lengthy. At the end I'll show you the complete connection diagram. These are the data inputs, data outputs, right? So again, it has two control signals, CE bar, chip enable, and the second pin determines the direction, AB/BA bar. So the chip enable bar will go to the microprocessor, pin number 26, your data enable, and the direction control bit will go to the pin number 27, data transmit or receive, right? So we need to short these wires. So chip enable of pin 19 will go to the same bus which has been connected to data enable bar, and the direction pin will go to the same pin which is connected to data transmit or receive. So my connections are almost done. I have demultiplexed my address lines, I have demultiplexed my data lines. The only task remain is completing all those interconnections and placing the labels. So as I have told you earlier, I'll show you the complete bigger picture. Over here, 8086 buses, right? So initially in my earlier design I have placed it horizontally, but in the final design I have placed it vertically. It's up to you which design that you choose. So as you can see, I've connected all the intermediate connections for your latches as well as your trans receivers. So I'll just give you one simple demo how to connect the wire and how to place the label. So first let me delete this wire. I've deleted the wire, so I'll make the connection and I'll place a label by right clicking, edit wire style, right clicking, or place wire label ED0. So accordingly you can give the labels for rest of your interconnection. This makes all your data lines and address lines demultiplexed at the output side. So this brings to the end of this session. In the next introductory session will be helping you with connecting memories to your 8086. Thank you.